All right. Okay, good. So, welcome back from the break of Eid. Eid Mubarak again. And today we will start a new chapter from the textbook of Adel Sidran Smith, Fundamentals of Microelectronics. So today we'll touch something a bit higher in terms of complexity, but it's not that complicated. It's very, very simple. You will see that we will not talk about those things that we studied before. It's your job to revise, okay? We'll talk about the first application, that is the diodes. So what are these diodes? We'll talk about them. Mainly we'll talk about the ideal diodes first. We'll see what are these ideal diodes and how we're gonna use them. We'll talk especially about their IV characteristic, means how they behave in terms of changing voltage and current. Especially, we'll talk about the models of the diodes. We have models for DC and AC. For DC models, we have 3. For AC, we have 1. And this is the most important model that we will use until the end of the course. Some applications we will finish this course with, namely regulators and rectifiers. In summary, we will cover today the IV characteristic of an ideal diode, talk about the modeling as I've shown you here. Okay, these are the 3 models for this DC analysis, and 1 model for the AC analysis, which is the very, very important. And then we'll finish with the real diode. So we'll start with the ideal diode. We'll talk about this first, the real diode. So ideal diode, then the real diode, then the modeling. And in between, we'll throw some applications. And next class, inshallah, we'll finish this chapter by the remaining models, especially these 3 models. Okay? All right, good. So what's an ideal diode? Okay? The ideal diode is basically, ideal means what?
Perfect.
Perfect. يعني مثالية. Something that is really perfect. And there is no perfection in life. So before we get to the perfect ideal diode, there's a mistake, first class of Week5. So the first thing, why we call it a diode. So diode, the name of diode comes from the word diode. Or sometimes it's called the diode. Diode or diode. And this word means مثنى أو 2. فهمنا ولا لا? And we call it diode because it's composed of 2. Of anode and cathode. Okay? So okay? Okay, good. So the diode is basically a junction, as I mentioned last time. And that junction has terminals, cathode and anode. And this is the symbol of the diode. It's like a triangle, okay, like this. And a bar like that. The bar show always the cathode, okay? And the triangle is always connected to the cathode is the bar and the anode is the side of the triangle. Meaning, the reference of the voltage is always with reference to the cathode. Means, this is our reference voltage. Means, if we apply a voltage on a diode, it will be with a reference with this. So if we say we apply a positive voltage, that means a positive voltage in here with respect to this voltage, okay? That means this voltage bigger than this. Now, if we say we apply a negative voltage, that means the voltage applied on the diode means here, with respect to this, is less. That means it's negative. So it's always VD, the diode, is V plus. So if you take VD, the voltage of the diode is going to be always V plus minus V minus. Okay? So this is the voltage applied on the diode. If V plus is bigger than V minus, we have a V diode positive. If V plus is less than V minus, VD will be negative. You understand? These are conventions to help us to understand. Now, what's the ideal diode? We talked about the symbol. We'll talk about now the model. How does it behave? So, the behavior of the diode is very simple. If the voltage applied on the diode, this is only the ideal diode so far, okay? If the diode is reverse biased, means VD is negative, then in that case, the diode will behave like an open circuit. Open circuit, that means it's cut, like a wire here is cut. So, if the voltage applied on the diode is less than 0, V means VD, is less than 0, the current is equal to 0 because it's open. When it's open, nothing will pass. صح ولا لا؟ صح? Good. Now, this is number one. Now, if the voltage applied on the diode is positive, or at least it's not negative, means from 0 and up, it behaves like a short circuit. Okay? So, basically, if the current is sent from the cathode, from the anode to the cathode, at a voltage a little bit above 0, or you can say 0, the diode will behave like short circuit. If we speak about these models, mathematically we always draw what we call the IV characteristic, the current on the y-axis and the voltage on the x-axis, okay? So for voltages that are negative, the current is equal to 0. This is an equation of a line, yes or no? This is an equation of a line. If you write this in terms of line, so this line basically says I is on the y-axis, that means y is equal to 0. This is the equation of this. Do you understand? This is the equation of this line. Do you understand? If you write the equation mathematically here, if you look at this equation, it means y or I is equal to 0. That's it. Now, and this is this part, when V is negative. When the voltage applied on the diode is just a little bit above 0, boom, it behaves like a short circuit. And for that matter, we have the equation of the line here, or on this segment, is V equal to 0. V is X. So if you want to write it, you can write this V is equal to 0 or X is equal to 0. And this is the equation of this line. Any point on this line has X is equal to 0. But Y can be anything, okay? Y can be anywhere. But X is always 0. They are not away from this line, okay? So this is the equation of this line, and this is the equation of this line. So instead of saying X and Y, we say just the voltage of the diode is 0 for forward bias, and the current of the diode is 0 for reverse bias. In mathematical way. Okay? Clear? Clear? Very good. So let's move on. All right. So we have, we're not going to speak about things that we have spoken about. This is also the same thing, so we're not going to waste our time. Now, we get to the practical side. Can you put short circuit between the battery poles? Can we take a battery and then put short circuit like a wire? Can we do that, yes or no? Yes? What happens if we do that? Which will burn? The wire will burn, that's right. Now if the wire is thick and good, strong, what will happen? It will burn if the wire is thin, صح ولا لا? Yes. Now if it is thick, strong, what will happen? The battery?
The battery will damage.
Will damage. If it is a lithium battery, maybe, it will burst. It will boom, explode. If it is a normal battery, it will deplete. يعني all the charge will disappear. خلاص. Do you understand? So never do short circuit with a battery. Do you understand? Because you will damage your battery. You put yourself maybe in a risk, and you will lose the power of the battery immediately almost. خلاص? Do you understand? How to protect yourself from that? By putting a resistor always in a series of something that can be short circuit. In this case, the diode. Because the diode can be short circuit, yes or no?
Yes.
When?
When V is positive.
When we are in forward bias. Yes. Correct. Very good. So that's why here in this case, we put always a resistor in series with diode to protect our battery and our circuit, especially the battery in this case. فهمنا ولا لا? So to study the diode behavior, we have to put what? A resistor in series with the diode. means that if the diode is in the short circuit form or in the forward bias, the resistor will do what? What's the role of a resistor in this case?
Reduce the current.
Exactly, limit. Reduce, صح, but the right word is to limit. To make the current limited. صح ولا لا? By what? By the resistance. لأنه the current is equal to what? The voltage cross divided by resistor. If the resistor is big enough, the current will be limited to good value. صح ولا لا? Do you understand? Very good. That's what we want. Okay? So thanks to the resistor, we can limit the amount of current that will be taken from the battery. If we take a huge amount of current, we'll make the battery die very quickly. And we have to charge it again or throw it. Do you understand? Good? So always when you deal with a diode, always put the resistor in parallel, in series with it. This is practical.
I have a question.
Yes.
When we apply voltage on this circuit, some of the current will go to the resistor, right?
Mm-hmm.
And the diode, how much current will take?
دقيقة, very good. But hold on a second. Now the current that pass by, they are in series, yes or no?
Yes.
That means the current that goes here will go there. If it is in forward, خلاص, it's short circuit, so the current from here there. There's no other branch that goes out. Wallah. All the current from here will go there.
And
No.
needs a resistor.
Exactly. No, the diode, we'll talk about the resistance of the diode, but when it is short circuit, there is no resistance, is equal to 0. Do you understand? Do you understand? That's why in this model, and that's a good question, that's why in this model here, in the short circuit case, in the forward, so because the resistance of the short circuit is always equal to 0, that resistance times the current will give me the voltage drop, yes or no?
Yes.
If the resistance is equal to 0, times I will be equal to what? 0. That's why the voltage across short circuit is always 0. Do you understand?
Yes.
Do you understand? Because the resistance of the short circuit is 0. If there was a resistance, we cannot say this. صح ولا لا?
Yeah.
We cannot. We can never do that. That means here, what does it mean? It means for the diode in the forward bias, any current you pass, still you will not have much of voltage drop. It's always V equal to 0 between the two terminals of the diode. Do you understand?
Yes.
Because the resistance is 0, and that's why it's like this. Do you understand? So like we said in the movie, if you remember, I put also those movies in the blackboard. In the forward, it passes any current. But in the reverse, stops. Do you understand? It stops because it's open circuit. It will not allow any current to pass in the reverse. But forward, everything goes. You put 1 amp, pass 1 amp. Okay? Because the voltage drop is always 0 across the diode, in the ideal case. In the ideal case. فهمنا ولا لا? Good. So, that's why we put here a resistor. Now, is this diode forward or reverse?
دكتور إذا كان الرفرنس.
Is it reverse or forward? This diode. Wait. There's some candidate over there. Reverse or forward? Forward, why? See? Okay. Who knows? Forward?
Because it's 10 and there is 0.
What's that?
Because the current here is 10, not 0.
No, forget about this current. Let's say I didn't show you this, right?
Because the plate of the...
Wait a second. You? Yeah, you. Yeah, again you. If we ignore this current, this diode is forward bias. I agree with them. Why?
Because the direction from positive to negative.
But how do you know the positive and negative?
Doctor.
Yes? 1
We
second.
know negative and positive by the reference. Reference is with the negative side.
Very good. Here we have the reference voltage.
Yes.
يعني the lowest voltage of the circuit. Okay? صح. And here what do we have?
Positive.
Yeah, because this is connected to a resistor. So even if there is no current here, let's say at the beginning we don't have any current, so there is no current, that means this voltage is the same everywhere here. صح ولا لا?
Yes.
There is no current, صح? And then this voltage is about 10 and this one is 0. So automatically this will be forward bias, صح ولا لا? Because the anode is bigger than the cathode, correct? The triangle is bigger than the bar, huh? So it's forward bias. In this case, we replace this by a short circuit, yes or no, in the ideal case? Now in the short circuit, how much the current now is going? How much to calculate the current? How much the current? How to calculate the current? Forget about this, huh? So is the voltage here, there's no voltage drop here because there's no resistance. So is this voltage, what's this voltage? Is this 0? And this voltage is what? Is this voltage? 10. So 10 minus 0 divided by 1K, it will be 10 volt divided by 1K will be 10 milliamp. Okay, good. See? That's why now we have this. Now in this case, see what we did? We just flipped the diode, yes or no? Want to flip it? So basically automatically it will be without any thinking, because now we put this guy in the lowest voltage and this one is the highest, connect to the highest, yes or no? So automatically it's reverse. So replace it with what? With open circuit. Very good. So in open circuit, how's the current here going? 0. There's no current. So if there is no current, so the voltage here, how much? 10, exactly, because there's no voltage drop, there's no current. So the voltage is the same everywhere. Correct? So this is how we analyze. We have to see what's the voltage across the diode to replace it with a model. فهمنا ولا لا؟ A model هو النموذج, يعني how it behaves. Boom, copy and paste. Take the model, plug it in. And by the way, until we finish this course mainly and this chapter, plug and play is most of the things that we're going to do. We take the model, put it in the circuit, and we analyze. Okay? But we need to know which model to use. Now this is the application. One of the applications of the diodes are the rectifiers. We'll talk about that many, many times. And the simple rectifier is this one. What does it mean, rectifier? A rectifier in English is from the word rectify. And rectify means something that is not going in straight, we make it straight. You understand? In this case, يعني in Arabic is called مقوم. نعطيه الصراط المستقيم. Okay? Now, in this application, what does it rectify basically? It rectifies the direction of the current. I'll show you how. This is an AC source. What do we know about the AC voltage or AC voltage supply? Change of what?
Time.
Yeah, هي صح. Change of what? Amplitude, yeah. Voltage, صح. Wait, and then what's the mean? Yeah, it's the change.
In the battery.
Positive and negative, صح ولا لا? So the current will go both ways, yes or no? Sometimes the current is going this way, sometimes going that way, صح ولا لا? That is the AC, yeah? Yes or no? It's positive and negative, voltage up and down, or current is going that way or that way. This is how it works in real life. This is what it is AC. Understand? Good. So, so here, let's say this is like this. This is what? The input. Okay, good. And here, basically, this is the positive cycle, and this is negative cycle. Okay. In the positive cycle of the voltage here, the diode, is it forward or reverse?
Forward.
Why?
From positive to negative.
Because this voltage is bigger than this, yes or no?
Yes.
صح ولا لا? Because we are applying here positive voltage across the resistor and the diode, like the same example we had just now. صح ولا لا? In this case, we replace the diode with what? Short circuit. Very good. So, do we have current?
Yes.
Yes, the current is going where? Clockwise or counterclockwise? Clockwise. Very good. So the current is going this way. The output voltage is taken across this resistor. And this is the lowest, and this is the highest. Means V out is equal V plus minus V minus. Is it positive or negative? V out, is it positive or negative? And how do we know? It's positive? Who said positive? Yes, go ahead. It's positive?
Yes.
Just tell me, whatever.
Because it's equal to the voltage of the.
I will tell you why.
Okay, yeah, that's good one. Yeah, that's good one because this is short circuit, because this positive. Good. But there is one strong argument, yeah?
Because the terminal, the positive is greater than
صحيح, I understand.
That's why it will be.
That's true. That's true. That's definitely true. It's the same answer like your friend. But here, the output voltage is positive for one reason, because the current moved actually this way. صح ولا لا? The current is always moving from high voltage to low voltage. Do you understand? This is the most important thing. Huh? This is what's the basic of electrical engineering. Okay? The current can never go from low voltage to high voltage. It's the other way. High voltage to low voltage. Now? That's why when I calculate V, the output is this voltage minus this voltage. When I do that, in this case, it's definitely positive. صح ولا لا? Then the current is moving in this direction. Good. Now we finished that. Now let's talk about this cycle. So let's say V input is negative. In this case, the diode is reverse or forward?
Reverse.
Reverse or forward? Very good. Why?
Because it goes from the lowest.
From low voltage to high.
But hold on a second. If it is now in the negative, that means this voltage here is less than this. It's opposite to the conversion here, okay? So this level, less than this, that means this is bigger than this. So in this case, it's open circuit. Okay, very good. When it is open circuit, what's the current going through the resistor?
Zero.
Zero. And the voltage V out is equal to what?
V1.
Hold on a second. Any answer? Yes? The voltage here is equal to the voltage of battery? How do you know?
No.
Wait a second. Any idea? How much is the output voltage? Yes? Oh, but how do you... Can you apply Ohm's law now? Why we cannot apply Ohm's law? Why not?
Open circuit.
Hold on, so no, it doesn't matter. Ohm's law is always correct. It doesn't say when it's open or short. صح ولا لا? Did we say that?
No.
خلاص, then that's it. Yeah, tell me Ohm's law here in this case. Apply Ohm's law here.
V equal IR.
صحيح. Good. Apply this voltage. Now, give her a chance. You are killing everybody. What's that? I is equal to 0. Huh? Continue.
0 times R, 0.
So the output voltage is? See? Is it negative? No. Do you understand? Simple. The thing, what we're learning is simple. It's actually a joke. Trust yourself, trust what you learn, okay? Do you understand? Do you understand? You have a problem on trusting the rules here, huh? You have to trust Mr. Ohm. He was not playing jokes, he was serious. So the current here is 0, very good, times the resistor is 0, so the output voltage is 0, very good. So after we finish this cycle, will come another cycle, yes or no? So output voltage, was it negative or can be negative?
No.
Cannot be negative. See? So we have taken an input that can be positive and negative, and we got an output that is always 0 in the minimum, يعني, but in the normal it can be what? Positive. So it's always above or equal 0. So it's always positive basically, correct? That's what we call a rectification. An input that goes this way, and the output that goes always positive, can never be negative. That's what we call rectification. We rectify the input voltage and made it in only one direction. The current will go only one direction, or it doesn't go at all. Okay? That's the concept of rectification. Very important. Good, and that's why we use it mainly in AC to DC converters. To convert, this is one of the stages to convert an AC signal or AC source to a DC source. We need the rectifiers. Did you get that? Last clear? Boom. The output is always positive. Still, the game is not over. We have other stuff. So we are not going to talk about that. We have already explained that with a nice curtain. Now, we have something gets spicy a little bit. Very good. For those who understand. I'm sure most of you understand. Now, let's talk about this. Now, what we had before, we had a resistor here and the diode there, but now we added this guy. This is also a rectifier, but let's see how does it rectify. Okay, let's take this VS, which is the input signal, input voltage. It's an AC. It's an AC voltage source. Okay, that can go up, positive, and down, negative. صح ولا لا?
Yes.
Now, let's start now here, from 0. If the voltage here is, for example, 0.1, let's a little bit above, huh? Or even 0. Does the diode conduct or no? Yeah, if the voltage here, Vs, here at the beginning. This is the time, صح ولا لا? So we say at the beginning of this time. The voltage was 0 or close to 0. Is the diode short or open?
Open.
صح دقيق. Who thinks that is open? It's fine to make a mistake. So who thinks that is short? That's short. You tell me. That's fine. I want you to tell me. That's good. I like that. So tell me why it's short.
Because of the voltage V0.
V? What's that?
We are in the 0.
This voltage is 0. Let's say this is almost equal to 0 volts. صح. We're at the beginning. Hang on back. Continue.
And if the other side will be 0 also.
But hold on a second. The voltage here, how much?
12.
12.
Just خلوها. Just a second. Let her finish.
Positive.
Let's say this is 12. صح ولا لا? It's connected here. Yes or no? Correct? Continue.
So it will be the bigger will be.
Which one is the bigger? When the diode will be short circuit?
Short circuit.
When it will be? انت قلتي short circuit, yes or no?
If it's in reverse.
It's in reverse now or forward? Now. In this case, is it forward or reverse? Okay. Well, it's forward if the volt. When's the condition to have forward? If the triangle or the anode is bigger than this. If this is bigger than this. صح ولا لا? Make sense? Now, is it really the case?
No.
No. So in this case, so it is?
Open.
And in this case, is it open or short? احنا قلنا short when it is okay, wait a second. Right, say short يعني forward, okay? To make it easy. Open, it means reverse. Okay? Hey, excuse me, do you understand? خلاص got it? You can write this note then. Make it easy for yourself. Very good. So it will remain open circuit as long as this voltage is less than 12. صح ولا لا? If this stays below 12, this is always open. صح ولا لا? Make sense? Because still reverse. Do you understand? So that's why we have, from this point, I will draw the current. I will draw the current because that's the important thing. So the current from here until this point is 0. When the voltage becomes above 12, just a little bit, then in this case, this will be short circuit and the current will pass. صح ولا لا? Will pass. And then it will go to 0 again when the voltage of the source goes below 12. صح ولا لا? So it goes 0, 0, 0, 0, 0, 0. Until next time when the input voltage becomes above 12, and then at that time, it'll go increase. Okay? And so on. See? So the current does not have a negative value. صح ولا لا? This is a rectification. Okay? You can see the rectification as a current or as a voltage. Same thing. Yes?
What if they both cathode and anode has the same voltage?
Very good question. It's an excellent question. If they have the same voltage, you can take it as short circuit. But as soon as it becomes negative, boom, it's open circuit. You understand? Because if they have the same delta V across it is 0. That means a short circuit. خلاص. You understand? It's already a short circuit if they have the same voltage. There's nothing we can do about that. صح? Good. Now, how much is the current here? How we calculate it?
V over.
What's V? V of what? Hold on a second. How do you calculate the current ID? In this case, we are not talking about this. This is 0. خلاص. We are done. صح ولا لا? We are talking about these areas. We are talking about this area. And this current.
We will take 12 volt.
No. Who can know? Yeah, wait, 1 second. Yes?
We will 12 minus if
Whoa, easy. Hold on. 12 minus Vs. Are you sure? Hold on a second. To calculate the current. Now, if it is, we are here, so this one is already short circuit. So how to calculate the current in this case of the circuit? Where? How do you calculate it? Using what? Across what? Exactly, across the resistance. صح. So which one, we take it from which one? This, how much is voltage here?
12.
صح. والvoltage اللي هنا؟ Zero. No, صح. والcurrent, how much is the current? Vs, then this one is bigger than this one, yes or no? صح ولا لا? So it will be ID is going to be equal Vs minus 12, that's right, divided by 100. Yes, that's it. That's that. And that Vs is sinusoidal, yes or no? That's why ID will also be sinusoidal. So I have to replace with sine, yes or no? Do you understand? And that's why it's like this. خلاص? Finish? This is how we analyze, huh? This is how we analyze. Open the curtain. We use now the second application, or one of the applications of the diode. Now in this case I have to go a little bit fast because we have taken enough time to understand. Now it's easy to understand, correct? So we need to know what's the voltage across the diode and then put the model and then analyze. Some of you do not still trust Mr. Ohm. Trust Mr. Ohm, huh? Do you understand? If you don't do that, you have no business in electrical engineering. You understand? Very good. So in this case, we apply the concept of the diode and use it as, the ideal diode in this case, as a logic. So in this circuit, we apply the logic gate. Which logic gate in this case? Here, this is the logic gate. Which one of the logic gates? Okay, who tell me the logic gates? What are the logic gates that you know? And? NAND? Or? XOR, etc. Very good. صح. أحسنت. Very good. So in the logic we are good. So think about that, and you know what logic 1 is like high volt, صح?
Yes.
Or logic 0 is low volt. يعني 0 volt. صح ولا لا? Let's apply this here. So in this case, what do you think this gate is? For AND, that means, okay, let me explain before you do. So these are the input of the logic, and this is the output. We apply voltage, we get voltage. Here we apply, here we measure. Have now? Cool? What do you think? This is an AND or what? XOR what? Why? Because you read it. So, can you explain now? Who can explain? It's OR, صح? Okay, who can explain why it's an OR gate?
Maybe the voltages are summing them. So it's
1 amp.
Yeah, go ahead.
1 amp. 1 amp. 3 input.
Explain.
We have 3 input and 1
So what? So because we have 3 input, 1 output, يعني it must be and can be also OR with a 3 input and 1 output.
Because we have them.
Ma? Because explain, it's fine to make a mistake. It's okay. Here in my class, it's good to make mistake. If you don't mistake, you don't learn. How is that? If you do mistake, it's very good for you. Can somebody make mistake? Yeah?
Because of the connection.
Yeah, but can you explain? هو دقيقة بس. OR gate, let's explain. OR gate, the output will be high when?
It's enough to have one high input.
Very good. One enough. One input is high, the output is high, automatically. Can you apply this here?
Yes.
Let's see. Go ahead and apply. What do you think?
If VA has a high voltage, V lambda will have a high voltage
Why?
because of the connection. So it's enough to have one gate.
But why this is high? If this high, this will become high, you said, right? Why?
Because we have the ground.
Just, yeah, go ahead, because
It's connected to the ground.
this one is connected to the ground. This?
No, not this one.
Which one?
The whole.
No, the ground is connected only here. This is where we have the ground. Yes, go ahead.
Because all diode is forward, so if it's
No, we are not talking about this. We are talking only about this A. صح ولا لا?
Yes.
Go ahead.
VA, it's positive.
It's high. Yes, it's high. Okay, then.
Okay, it will be short circuit.
Why?
Because it's forward.
Why? Because, yeah, go ahead. It's
Because,
forward, yeah.
High voltage
And this is low. So at the very beginning, there is no current. And now we apply a voltage here. So here at the beginning, 0, right? It's a ground. There's no current, yes or no?
Yes.
So the whole thing is ground. And as soon as we apply a voltage here, or here, or here, the diode will conduct. صح ولا لا? As soon as it conducts, it will be short circuit and the voltage here will be the same. صح ولا لا? And output will be as high as the input. Yes or no? So the input is high, the output is high. صح ولا لا? We have only one enough to make this high. Very good. Do you understand? You got it? You understand? I just added the beginning only, because that's what helps in the analysis, okay? You got it? Now? So if only one is high, this output will be high. That's OR gate. Bingo. صح ولا لا? OR gate says if only is high, only one input is high, the output is high. This is OR gate. Automatically. صح ولا لا? We understand that? Very good. We come to this gate now. We apply the same concept. صح ولا لا? So let's see which logic is this without reading the board. The logic here is why? Okay, we go back to the AND logic. The AND logic says what? When we can have high in the AND logic.
All of them have high.
Very good. So the condition to have high at the output of an AND gate is at all the input are high. Means this and this and this at the input must be high. فهمنا ولا لا? All of them. صح. Can we apply this here? Okay, let's see. If all of them are high voltage, can the current pass?
No.
Why?
Open circuit.
Exactly, it's open circuit. Because actually before reaching that, if only one is, let's say this is low. If this is low, is this diode going to conduct? Let's say this is high, and this is low. How much is the output in this case? Why? But why? Why is an AND gate?
It's open circuit.
Okay, can somebody tell me in this case what's the output voltage here?
0. Because
Why?
I equals 0.
Because what?
I equals 0. Open circuit.
I is equal to 0, so this is becomes 0? How? Hold on a second. Who can explain?
Because the current will go through the.
Very good. Actually, in this case, the current will go through this because this is forward. صح ولا لا? There's no magic. So in this case, because short circuit, the voltage here is the same everywhere. صح ولا لا? So in this case, this is 0. This must be what? 0. You understand? So to stop this current from here and from here and from here, if we stop the current to pass by any one of these, to do that, this also has to be 1. So all of them have to be 1 to block all the diodes here, here and here. In this case, we stop all the currents from passing by any of the diodes. صح ولا لا? In this case, if the current doesn't pass, that means the current here is going to be equal to 0. That means the voltage over all this is the same. صح ولا لا? And how much it is?
5.
So it is high. So the output is high because all the input is high. So which logic is this?
Sir, I have a question.
Go ahead.
How can we tell like this circuit follows the old logic and the other one against?
Just by trying. That's it. Very good question. You try here. You know the truth table for every logic. صح ولا لا?
Yes.
So all what you do, you try. Put here high مثلا or 0 1 0. Try to play with the possibilities here. How many possibilities here? We have 8. If you try all the possibilities, automatically you will get the truth table of the gate of this, and you will know which logic is this. Or in this case, because I know what it is, I just give you the exact answer. Why? Because here I know for an OR gate, it cannot be high except only one case. It can be high if at least I have one is high. So in real life, if you want to be really detailed, you go and try all 0, 0, 0. You know the truth table. You apply all the possibilities here and you get this, and you can look, is this OR and or whatever. And you will know that this is OR. In this case, I just make it quick and go to the logic, okay? Which says that the output is high if I only have only one is high, which is automatically an OR gate. You understand? The خاصية عامة للOR gate. Boom. I have that one. I use that one. Boom. Or you can go and you say, no, I don't use the خاصية عامة. I go with truth table and fill it up. Try all the inputs, calculate the output. You understand? Good question. All right. That's it. So we are not going to repeat this. We have already explained. Okay. All right. Good. Let's see. Now, what if we have now multiple diodes in the circuit? If we have a circuit that has many diodes, and then we want to analyze the circuit. Which معنى analyze the circuit? To know what?
To know the voltage.
To know the voltages and currents of the circuit. That's the point. But the problem with the diodes, we do not know how they behave until we know the voltage across them. So the analysis is to find the voltages. But to find the voltages in this case, I need to know the voltage across the diodes. So it's like the egg and chicken. Which one comes first? It's a problem. We cannot solve this unless we have the voltages across the diodes, because the model of the diode is either open or short. And we cannot use the model unless we know what's the voltage across the diode. In the circuit, we don't know. It's a circuit, it's a big circuit. We cannot. So what to do in this case? We do what we do in math. We do assumptions. So we take the diodes, we have the circuit of the diodes, diode 1, 2, 3, 4, okay? And we make assumptions. I assume D1 is on, okay, first assumption. Let's say we have the circuit before. There's how many assumptions? There's either they are on or on, off. So let's say previous circuit, previous circuit. The previous circuit. So D1 is, let's say, is on. On means short circuit. Off means open circuit. It's like the switch on and off. Do you understand? So D1 is on, D2 is off. Okay? But second, I will not write in 1, 2. So on, off, it will be off, 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 on, or on, on. That's it. خلاص. Enough. I don't want to repeat. Lazy. Okay? Good. We have 4 possibilities. This is for that simple circuit. If you have 3, how many possibilities? 8. If we have 4,
16.
yeah, you see the possibilities are growing. Problems. But what we do with the possibilities? First, we take one possibility. Let's say we start with the first one. We assume and know diode 1 is on, diode 2 is off. And then we do the analysis. We know how to replace with the model for on and off. On short circuit, off open circuit. And we do KCL, KVL, and bingo. We have the voltages and currents. And then what do we do? And then after doing this, okay, we check for coherence. إيش معنى coherence? Coherence, that means the result are in agreement with the assumption. ما فيش تناقض بين الاسsumption تاعنا والresults تاعنا. بمعنى, for example, if we take this first assumption, فرضية الأولى, okay? If we find, after doing the analysis, if we find the voltage across D1 is negative, is it in coherence? ولا لا? Let's say we solve this, and we found that VD1 is actually less than 0. Let's say we did that, huh? Is this in coherence with this or لا؟ لا متناقضة صح ولا لا؟ من جهة تقول it's on ومن جهة result تقول لا it's off. In this case what do? We say that the assumption is wrong. So bye-bye the assumption. Bye-bye. This is not true. صح ولا لا؟ Then we go to the next one. Or simply we flip, instead of D1 is on, we make it off. Okay? And then we repeat this analysis. And we finish by double checking if the results are in coherence, يعني تطابقية مع الفرضيات, مع assumptions or not. Do you understand? Good? Clear?
Yes.
When the results now match the assumption, any assumption we do, that's the solution. That means we found how the diodes are, which diode is on, which diode is off. And then the results that we found, currents and voltages, are correct. Finish. We finished the analysis. Come to? This is the case when we have multiple diodes inside a circuit. Do you understand? Very simple. It's not complicated. Good. Also, there is another condition here. For example, not only we check the voltages, we check also the currents. بمعنى, if the currents, let's say, before I jump there, if we assume, for example, this one is on, for example, D1 is on, and then we found, that the current is going this way. Is it in coherence? The result? No, it's not in coherence. Because if it is on, the current will go only in one direction, which is from the anode to the cathode, on this direction. Yes or no?
Yes.
If it goes the other way, that means it's not in coherence. لأنه delta V لنا, if you remember, is 0. صح ولا لا? If it is on. But the current has to go this way, not that way. Do you understand? Do you understand?
Yes.
So not only we check for the voltage, we check also for the direction of the current. فهمنا ولا لا? Do you understand? So we have to make sure and the diode works the way that it's supposed to work. Okay? Not otherwise. If it is in contradiction, then that assumption is wrong. Change, analyze again, and double check. فهمنا? It's a little bit tedious, this thing. A little bit hard, actually. Very hard sometimes. So that's why we use, in this case, what we use? We use programming. Okay? Okay. That's it. We use programming for this kind of circuits because it's machine work. Usually we program. We tell the program, do this assumption. If not, check the second, and we loop. Because there is a loop. And we know when to exit the loop. When the assumption is correct, it means it's in coherence with the result. Our result match our assumption. We stop and we get out of the loop. And we give it to the user. Okay? We give it to the manager to give some money to us as a thank you thing. Okay? Very good. Now, this is the ideal diode. خلصنا ideal diode. We get to the real life. This is the real life, the real junction diode. That sometimes we call them junction diode or diode unknown because we know the diodes are made of junction. Okay? Good. So this is the real diode. Again, the real diode, as you can see, the IV characteristic, always I is in the y-axis and the voltage in the x-axis. IV characteristic. For ohms for the resistor characteristic.
Equal to slope.
It's like what? It's like a line. صح ولا لا? It's like a line that goes cross zero والله هنا. Always cross zero. It can be here, it can be here, it can be here. It can be negative. For now, forget about this. It can be negative, yes. But for now, do not bother yourself with that, okay? So for now, let's assume that everything is good. So for now, for resistor, it's always like this. So a line like what? Like this. Okay? So the high resistance is this or this? Which one is it? This is the high resistance or this? This is what? Which axis is this, the green? This is the current. The current here. And this is always what? The voltage. So the slope. So here, the slope is the resistance or the inverse of the resistance in this case? Inverse of the resistance. Because here the slope is delta I over delta V. Yes or no?
Yes.
But the resistance is delta V over delta I. Yes or no? So this is 1 over R. It means this highest resistance or this one?
The lowest one.
This is the lowest resistance. So the closer the line to the vertical axis, the smaller is the resistance. The closer this line to the V axis, that's where the higher resistance. Do you understand? Got it? You will see that here too. So this is again Mr. Ohm. Good. Now, for the diode is not exactly the same, but it's a little bit interesting. The real diode, if you remember, we said that it has exponential behavior. I have to go a little bit quick because we don't have much time. So the real diode does not conduct a current until a voltage across the diode is above a certain threshold. A threshold, or we call it a cut-in. So threshold. Threshold, okay? Above the threshold, the current will be exponential, and the current is going to be equal IS EV over VT. The current that we studied before, okay? If the reverse is, if it is in the reverse bias, the current will be, of course, equal to minus IS. Remember that? Minus IS. We did that last time. But now, if the current is more negative above a certain value, we call it Zener-Knee value voltage. In that case, the diode will not only, here it's open circuit, here it will conduct actually, okay? It will conduct, and the zone of operation, we call it the breakdown. We'll explain them in step by step. So we have 3 zones. We have the forward bias, which is this case, the reverse bias, and the breakdown bias. The breakdown bias or region, that's fine. In the forward bias, the current is the current that we studied, yes or no? If the voltage is a bit higher, we can ignore this -1, and we use that equation, okay, for forward bias. Very good. If we take that equation, the exponential equation, this one, we can get the voltage in versus the current, yes or no? You know how we get this? Simple. Very good. So this equation is quite interesting. Why? Because the logarithm function does compress. Logarithm of like 100, if we take base of 10, it will be almost equal to 2. Yes or no? So 100 is the input. 100 here in this case, it means the current is 100 times the saturation current. See, 100 times. Logarithm of that is 2. See, it's compressed the value, give you small value. Times Vt, which is how much? 25 millivolt. So the voltage is not going to change that much. Okay? So this, we call it the compression, the compressive, if you want, the compressive nature of logarithm function. Logarithm Neperian, or later on we can also use log of base 10. Okay?
Doctor, this is for forward. Right?
Yeah, we are talking about forward here. We're not talking about. Forget about this. We are not talking about this. Forget about this. Okay? Here it's talking about something else. Previous equation may be reversed to yield the following equation. Reversed. It's not the reverse by. Reversed means instead of finding the current from the voltage, we are finding the voltage from the current. Do you understand? It's not the reverse current or reverse that. Okay, now to understand this concept very easily, if we take 2 measurements of current in the forward bias, I1 at V1 and I2 at V2, okay, and we divide these 2 equations on top of each other, this divided by that, boom, boom, and then this done, okay? What's that?
IS will cancel.
Yeah, they will cancel each other, blah, 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 blah. We reach this equation. صح ولا لا? I don't have to show you that. You know this, huh?
Yes.
It's easy. Very good. Now, instead of using logarithm Neperian, I will use log of base 10. You know how we do that? It's very simple. The log of base 10 of a certain number n is equal to what? Is the log of n log the Neperian log of n. Oh, sorry, I'm confused sometimes here. Log of n, okay, divided by the log Neperian of the number 10. Okay, you understand? So here, so log of this, we can replace it by the log base 10 of this times the log of 10 Neperian, which is 2.3. Do you understand? So this times the log base 10 give me the log of this. Okay? So this equation is the same as this, and you can double check this equation at home if you want to understand the log basis. Now, what does it mean? It means the same thing that I said just now. If we assume that the current, when we change the voltage to V2, and we make the current here 10 times this current, how much the voltage really between V2 and V1? So if I2 is 10 times I1, log base 10 of number 10 is equal to 1, yes or no?
Yes.
So this is equal to 1 times 2.3 times Vt. This is almost 20 millivolt. So the current has been increased 10 times, but the voltage across the diode has been increased by just 60 millivolt, يعني 0.06 volt. Seems like nothing. صح ولا لا? So the current has changed a lot with a very change of voltage. That's what I mean by the compressive nature of logarithm. So the current changed a lot, but the voltage does not change a lot. Why? Because when the diode is on, the resistance of the diode is really, really small. That's why the ideal diode is short circuit. Because the resistance of the diode in the forward bias is almost zero. Do you understand? Because the current can be increased too many times, like 10 times, and the voltage will not increase by much. Why? Because the resistance is very small. Got it? Very good. All right, one more thing actually. In the conductive, this is what we call the fully conductive region here of the forward bias. You can see that this is very close to this axis, means almost is very parallel to it. It's like short circuit. صح ولا لا? The resistance is very small. It's not close to this. It's close to that. Do you understand? So automatically when you look at the graph, ooh, the resistance is very small here. See? You become expert. Good, almost there. Okay, please switch off the thing. Now we said something else before. We said that the diode, the real diode, will not start from zero. Actually, it starts from a certain voltage. We call it the cut-in voltage, or we call it the threshold voltage. Okay? That's it. This is, and this threshold voltage typically is between 0.6 volt and 0.8 volt, between these two values. Okay? So it's not huge. The reverse bias region, it means before we reach when the voltage of the diode is negative. In this case, if we apply the equation there, we can get that the current of the diode is equal to minus Is, and we said that the saturation current is quite small. It's actually in the range of 10 minus 9 or 10 minus 14 amps. Extremely, extremely small, okay? You have to have a very good ammeter to measure that current, okay? That's it for that. So the real diode, as I said, exhibit that. And that current, we call it the saturation current, or we call it the leakage current, okay? Just we know how it is. Now the last zone, which is very important to know, is the breakdown. It means when we reverse bias the diode too much, we can make that diode conduct in the reverse region, and the current will go extremely high, you see, but in the opposite direction. So in this case, the current is going from the minus to the plus here, from the cathode to the anode. So here, if we take the diode like that, so now the current is going this way, okay, in the breakdown region. We call this value beyond which the breakdown will take place, will happen. We call it Zener knee voltage. Zener, for the scientists to find it. Knee means rukba. This is like this. See? We call it Zener knee voltage. No, it's like the knee. Rukba, okay? That's the knee. Because it's like the knee. هذا الفخذ وهذا الساق. هذا الركبة. Engineers are humans after all, okay? Now, if the voltage now goes back here, the breakdown will stop. معناته أنه this phenomena, what happens here is non-destructive. بمعنى أنه the diode does not break down here. It's not breakdown. It's just the name we call it breakdown. But if the voltage comes back here, the diode will be in the reverse. I mean, almost like open circuit, and works normally. So it's not destructive. That's it for the regions. This is a summary of that. And before we leave, we'll talk briefly about the models of the diodes, real diode, the exponential, the constant, voltage drop. The ideal model, خلاص, we are done with that. Okay. The exponential, we'll go through it very quickly now. And this will do it, this and this will do it next class, okay? The exponential, we know it. I will go very, very quickly with that. The exponential model, it just tells me that the diode current has an exponential function with the diode voltage. Okay, give me the voltage, I give you the current. There's nothing big difficult with it. But the problem with that is the calculation is a bit, difficult in circuit analysis. Let's see. If we have this kind of circuit, for example, diode, a resistor and battery, how to apply the exponential? We have two ways of applying the exponential model. Whether you use it graphically, so this is method number one, or we use it iteratively. The graphical one is a joke. It's very easy. So the idea is the following. We have a current that passes by the resistor, which is the same as the current passing by the diode. Okay?
Yes.
Very good. The equation for the diode, we know it. I is equal to Is, E exponential V over Vt, صح? Now, the equation for the resistor is equal to what? Is equal to this voltage minus this voltage, because we have taken already the current going this way. This minus this, divide by R, yes or no? So this is the characteristic of this resistance, or the IV characteristic of the resistor. And the previous one here, this one, is the IV characteristic of the diode. That's it. We put these two equations in one graph. So this is the graph of the diode, and this is the graph of the line. Yes or no? You know what's X, so you know what's Y. Y is I, is the current, and X is V. Don't make this mistake. I've seen this mistake many times, okay? Good. We draw them together, and then to know the current and the voltage across the diode, I just look at the intersection of the two. Because that means that's where the resistance and the diode, they will share the same current. That is this current. They have to share the same current. Because they are in series.
Yes.
Good. And the voltage across the diode, I can get it from here, from this point, it will be this. So I know exactly how much the voltage across the diode, and automatically I can know the voltage of the resistor as well, okay? Good, so this is the graphical way. Now, what is the iterative way? The iterative way is very simple. But before that, let's see what's the problem with this method. The problem with this method is that, well, let's start with the good stuff, the pros. What is positive about it is visual, natural, but the problem with this is that you have to draw. Everyone has his own way of drawing, and mistakes will happen. So this point cannot be really accurately found. So it's less precise, and also not practical if we have a big circuit. So this method, we will not use it most of the time. The iterative method is the one that we will finish today's class with, okay? So first, in that circuit or any other circuit, we start with a guess voltage across the diode. That will come with the diode data sheet. So the manufacturer will sell you the diode, you look at the data sheet. You know what's data sheet?
Yes.
Very good. So look at the data sheet, tell your manufacturer, okay, fine. So this diode will pass 1 milliamp when the voltage across the diode is, say, 1 volt. So we'll tell him, thank you very much. That point we call it the guess. It's a good point to start with. Very good. So we start with that, or we can assume, and then we use, so that's the voltage across the diode. So I go to the circuit, I put that voltage, what is that? I put that voltage across the diode. That's VD0, okay? And then I calculate the current, yes or no? The new current. So I start with VD0, which has also ID0. I diode 0. It means the first one, the first values, okay? So VD0, ID0, the first 2 points of the diode. And so I put the voltage here, I calculate the current here, which will be the new current. Very good. And then I do what? I go to this equation. Which equation? Remember the equation where we have two values of voltage and current? We'll use that one. Okay, let's see that. We'll use this equation. This equation. So here, so what you found here at V1 will be the first V and I1, the first I, okay? These are the 2 points, or the point, the coordinate of the first point that we know. And I2 here will be the current that I just calculate. So from here, what do I need to know? I need to know this. I will find V2, the new voltage across the diode. This is the equation that we will use for iterative solution. So, okay. So we'll go forward a little bit. Okay. Then after we do that, what will happen, sir? Very simple. What will happen is that I found now the new voltage. I will check this voltage with this voltage. If this voltage is the same as the previous voltage, I stop. I say, I found the solution, it did not change. Now, is this voltage different? I repeat. So I will use this one, and I calculate the current, and I'll get a new voltage, and I compare, dun, 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 dun. I repeat, until when? Until the voltage of the diode does not change. That's why we call it iterative. Repeat, until the voltage of the diode is constant. Boom. At that time I stop and I have the exact value. The nice thing about this is it's very high precision. Boom. Gives the value very accurately. It's not practical for complex circuits. It's very hard. Okay? If you have too many diodes or too many resistors. Okay? This is the problem. So you pay for the high precision because the iterations also sometimes can be really too many. That's it. And next class we start. Thank you very much.